Hey guys, now that you went over how to create the unit circle quicker, make sure you practice that because yes, as you do your homework, you're going to be able to look at a unit circle, but on the test, if it's non-calculator, you're going to have to memorize that. The best thing to do is every day, just draw a circle and start doing that. Now, if you had me before, of course, I tested you and I wanted you to do it under what, 5 minutes? But the truth is, you don't have to do it under 5 minutes, but you have to watch out for the timing of your test, okay? So let's review some basic trig. So we have our SOHCAHTOA and our 6 trig functions. So remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Cosecant is the reciprocal of sine. So really, we can also say that this is hypotenuse over opposite. We can say secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. Okay? So we're going to use these things. Now remember, if you are only given 2 sides, you need to use the Pythagorean theorem, okay? So what we're going to do is use this right triangle to find these trig functions. What's very important is this. As you can see, it says theta. Now, if we had let's say we had beta here, you would have to do the trig function from beta. But since it's theta, we have to do it from this angle. Now, I might right away go, okay, that 4 is opposite, that 3 is adjacent, and that 5 is the hypotenuse. Because now I can automatically put it in the ratios. Sometimes you will have to simplify. Sometimes you do not want a radical in the denominator, so you need to be careful on how you simplify that. So sine, of course, is opposite, which is 4, over hypotenuse, which is 5. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Secant, let's remember, secant is reciprocal of cosine. So that means I'm just going to switch it to 5/3. Okay, and that's your basic stuff. Now, when you do trigonometry and stuff like that, or the functions, usually it's around that unit circle. And they talk about vertex, initial side, terminal side, all that stuff. Not many teachers introduce the trigonometry like that, so make sure you pay attention to some of the things I'm talking about if you've never seen it this way. So, angles in a right triangle must be positive and less than or equal to 90 degrees. A less restrictive way of defining trigonometric trig ratios is to use angles that can be any measure. At right is an angle in standard form or in standard position. The vertex of the angle is the origin, so that will always be that. The terminal side of the angle is the positive x-axis, and in the figure shown, the terminal side is formed by counterclockwise rotation, okay, counterclockwise. So when you guys think of this, remember that we have radians, we have circular, okay? So instead of sine as opposite over hypotenuse, you got to think of it in this form. You have your x value, which is your cosine, your y value, which is your sine, and your radius of your circle. So this is why when we have an angle right here, the opposite is y, the adjacent is x, and the hypotenuse is r. So this is another form to write it in. So instead of saying opposite over hypotenuse, we say y over r, x over r, y over x, so on and so forth. Now, of course, r is the square root of x squared plus y squared. You got to remember that that's just the Pythagorean theorem, right? So it's just in forms of x, y, and r. Theta is your measure, okay? And then y and x may be positive or negative or 0, okay? So remember the coordinates of your unit circle. All right, so what we're going to do here is we're going to practice doing that with example 2 here. So we're going to find sine, cosecant, cotangent if theta is an angle in standard position whose terminal side passes through -5, 2. So let's show you what that looks like. So we have our xy axis and we have our coordinate pair of -5, 2. Okay, so if I look at a place right now, it's because somebody knocked on my door and I had to talk to them. So let me go through this again. We are using the terminal side that passes through the point -5, 2. So -5, 2 is going to be up here somewhere, right? So I'm going to draw that in. So this is going to be -5 right here. This is going to be 2. So we're going to use the Pythagorean theorem, remember? So r equals the square root of 25 plus 4, which of course is the square root of 29, and that cannot be reduced. So I'm just going to put the square root of 29. And I know that the angle is going from here. Okay. So what we are going to do at this moment is we are going to do sine of theta, which equals opposite, remember, so right here, right? Opposite, which is 2 over hypotenuse, or gosh, I'm using the regular stuff. I mean, y over r. We have cosecant. Cosecant is the reciprocal, so it's r over y. Then we have cotangent, which is x over y, so -5 over 2. Okay, that's just, be careful when you do your work, look at the instructions of what they actually want you to do, so you're not doing too much. All right, circular function in trigonometry makes you use reference angles in triangles, and is really not much different from right triangle trig. Okay, so this is where we go over our special right triangles, which this is why in the unit circle you got those 1/2 square root of 3 over 2, square root of 2 over 2. Okay, so our first one is our 30, 60, 90, and I will tell you that I'm probably not going to get, did I do that? Oh, that looks okay. So that's 30, 60, and 90. So what happens is that the radius or the hypotenuse is going to be 2. Across from 30 is 1, and the square root of 3. Now, how do I know that that is 1? The idea is we would have had x, 2x, so on and so forth, okay? Because remember, the radius of a unit circle is 1. Okay, and then we have the 45, 45, 90. Of course, this one doesn't look as good, but we'll deal. 45, 45. And we get, remember, since the 45s are the same, so are the sides across from it. Do the Pythagorean theorem, we get square root of 2. So those are our special right triangles. That is where we got our unit circle, okay? Now, example 3, draw angles in standard position and make a reference triangle. Okay, so standard position 210 is, if we go all the way down to 210, we're right here. Okay, so when we do our reference triangle, this is standard position, we go up to the x-axis, right? as you can see, this right here from 180 to 210 is 30 degrees. And this would be our 60. Well, again, what's across from the 30? 1. What's the hypotenuse? 2. And what is across from 60? Square root of 3. Now, the biggest thing I want you to remember, though, is what quadrant are we in? We are in the third quadrant, so our x and our y are both negative. Okay, let's do that again. Oh, wait, we still need to solve for it, right? Cosine, remember, cosine is x over r. So our x in this case is negative square root of 3, and our r is 2. For tangent 315, so I'm going to go all the way around here to 315, draw my reference triangle, and of course you see that from, let's see, 270 to 315 is a 45. So I know this is a 45, 45, 90. Across from the 45s are 1. And the radius is square root of 2. I also know that I'm in the fourth quadrant, so x is positive, y is negative. Oops, I put the negative in the wrong place. And tangent is, I'm going to do that. Tangent is y over x. So that means the y value is -1, the x value is 1, which of course reduces to -1. So the reference triangles allow us to build the unit circle. But I'm not going to go through a lot of that since we did that the last couple of years, and I did the video on it. Okay, for those of you who need the converting of the pi or radians to the degree, hold on one second. We need to remember that 2 pi equals 360 and pi is 180. Think of that. Around a circle is 360. We know around a circle is 2 pi. So of course pi makes 180. Now how do we usually convert that? Well, we can change all these pi's to 180 and then divide. So 180 divided by 2 is 90 degrees. 180 divided by 4 is 45 degrees. Pi, or 180 divided by 3 is 60 degrees. And 180 divided by 6 is 30 degrees. Again, something you guys might already knew. We did build the unit circle. Now, what we want to do is here, we want to do this without a calculator. So 5 pi over 4. Again, we can look at this as 5 times 180 divided by 4. Well, we know that 180 divided by 4 is 45. So we get 5 times 45, which equals 225. So it depends on what you need to do this without a calculator, okay guys? Now 270, again, we can memorize what we did from the unit circle, or we could think of this as, this is 3 times 90 degrees. We already know that 90 degrees is pi over 2. So we get our 3 pi over 2. Okay, now here, negative, what we're going to do is just keep that negative there. I know 120 is 2 times 60, and we already went above that. 60 is also pi over 3. So we know that a negative 120 degrees is negative 2 pi over 3. Now, very quickly, negatives, which I guess we will do down here. Negatives means that you're going clockwise, okay? Counterclockwise is your positive degrees. Clockwise is your negative. So let's draw some angles in standard position and make reference triangles without using a calculator. So 5 pi over 6. Again, if you need to do that in your head, go for it. Or we can actually go back to the unit circle, draw it out really quick, and remember that 5 pi over 6 is over here. It's at 150 degrees, okay? Now, we also know that this is, if this is 180 and this is 150, that this angle here must be 30. So we have our 1, 2, and square root of 3. Don't forget we're in the second quadrant, so our x is negative and our y is positive. And tangent, remember, is our y value over our x value. You do not have to simplify in this case. Most of the time you don't have to simplify. Okay, so keep it as negative 1 over the square root of 3. Now, be careful with this, negative 3 pi over 4. So what that means is that we are going negative 135 degrees. We can change that. So we start here, and this is negative 90 right here. This would be negative 180, so we're in here. Okay, which makes this a 45-degree angle. So we have 1 square root of 2. We have this being negative and this being negative. Cosine is x over the radius, so that's negative 1 over the square root of 2. Cosecant, 5 pi over 3. So 5 pi over 3 is 300. Again, we can memorize the unit circle and know that right away, that that's where 5 pi over 3 is, which also means that this is a 60-degree angle. So we have square root of 3, we have 2 and 1. And let's remember what's negative, that's positive, that square root of 3 is negative. Cosecant. Cosecant is r over x. So our answer is 2 over the negative square root of 3. All right, one more page, guys. This one's going to be a lot easier because hopefully you have been practicing your unit circle, or will be, so you can have it out. Just remembering the coordinates, right? So do your unit circle from the last video, and we could go straight by using this. So sine of pi over 6, that equals 1/2. Sine of 0, so let's look at this. At 0, our coordinate point is 1, 0. And remember, this is cosine sine. So sine equals 0. At cosine of 0, it equals 1. Remember that this coordinate is 0, 1. So the sine is 1. The cosine is 0. Same thing with our pi. We have negative 1, 0. So sine is 0. Tangent. So remember, tangent is sine over cosine. So that is 0 over negative 1, which of course we just put down as 0. 3 pi over 2, that coordinate is 0, negative 1. So sine in this case is negative 1. Cosine is 0. Okay, here's our tricky ones. Cosine of negative pi. So remember, negative, we're going counterclockwise, but really negative pi is the same thing as pi. What is the cosine? Negative 1. Tangent of negative pi over 2, so backwards. So negative pi over 2 is the same thing as 3 pi over 2. And tangent is sine over cosine, so we get undefined because that's negative 1 over 0. Oh my gosh, I'm almost done, and I hope nobody comes in. Okay, so here we go. Other things that I've shown you before in the unit circle. Tangent is sine over cosine. Cotangent is just the reciprocal, so on and so forth. So when we know one of them, we can find the other ones, okay? So sine is 3 over 5, which means cosecant's just the reciprocal. So we get 5 over 3. Now, what connection does sine and cosine have? They really don't. So what we have to do is draw our right triangle. So if this was theta here, that means the opposite is 3, hypotenuse is 5. We can use the Pythagorean theorem to find the other side, which would be 4. Now, sine is positive, but as you can see from our unit circle, we have 2 spots that are positive. So we also have to have 2 cosines. If we talk about the sine being positive here, that means the cosine is going to be 4 over 5. But if you talk about the sine of 3 over 5 here, we get negative 4 over 5. So we have to think about it in both places, okay? Tangent. So we already can use our reference here. And again, when we have sine being positive, we have 2 tangents. Oops, 2 tangents. So look at our right triangle here. Tangent would be opposite over adjacent, which is 3/4. But again, we have 2 of them. By the way, you can either write it as 2 separate ones or together. All right, one more part, guys, working backwards. So this is solving. Again, if you have your unit circle memorized, you can draw it really quickly and then go from there. So cosecant, of course, we don't really think of cosecant on our unit circle. So what we might need to do is flip it and think of it as sine x equals negative square root of 3 over 2. So on your unit circle right now, look for negative square root of 3 over 2. Remember, there are 2 places that sine is negative square root of 3 over 2. So when you look at that, hopefully you got 4 pi over 3 and 5 pi over 3. All right, so cotangent. Let's flip it to tangent. And we get 1 over the square root of 3. Now, one thing we did not do on our unit circle was actually put in our tangents. But what I also want you to think of is this. I want you to think of that we use the values of 1/2 and square root of 3 over 2, right? So that's where the 2's cancel. And if you remember, tangent is sine over cosine. So find out where you are on your unit circle, where sine is 1/2 and cosine is square root of 3 over 2. Now, of course, right away you can see that we have pi over 6. Okay? Here's the other thing. If tangent is going to be positive, can't we have a positive over a positive, what we do right here, but we also can have a negative over a negative. So find on your unit circle where sine is negative 1/2 and cosine is negative square root of 3 over 2. And you will get 7 pi over 6. All right, this one more here. Let's just look at notes here. You have to solve a little bit first. So keep in mind that a square after the cosine just means the whole cosine of theta is squared. Okay, so let's solve. So I'm going to add 1 first to both sides. I'm going to divide by 2. Now, how do you get rid of a square? You take the square root. So we end up getting that cosine of theta equals the square root of 1 over 2. Couple things, let's talk about this. When you take a square root, how many answers do you actually get? You get 2. You get a plus and a minus. Now, many of you might be thinking, well, Ms. Heckman, I don't see square root of 1 over 2 on my unit circle. Well, think of this. Saying this, the square root of 1/2, is the same thing as saying the square root of 1 over the square root of 2. What is the square root of 1? The square root of 1. So square root of 1 is 1 over the square root of 2. Okay, so if you look though, some of you again are going, Ms. Heckman, I don't have 1 over the square root of 2. That's because the unit circle we made was simplified, where the square root was not in the denominator. The simplified version of this is plus or minus the square root of 2 over 2. If you can't remember how to simplify this, make sure you ask me about this later. Now, of course, I just solved, but I did not give the answers. So where on your unit circle do we have plus or minus cosine being the square root of 2 over 2? So remember, cosine is the first part of your coordinate, and you should know that we have 4 answers for this. So our first one's at 45. Why did I put theta? So pi over 4. Then we have 3 pi over 4, 5 pi over 4, and 7 pi over 4. There's the bell again. If you see, guys, I've written all answers in radian form. That is, I did that on purpose. All your calculus stuff will be in radians. Yes, it's easier to think of degrees, but your answers, your questions will most likely be in radians. So be ready to do that conversion. All right, now you can try your practice work.